Hello, and welcome to Patch Math, where today we are going to continue patching your math knowledge on systems of linear equations, focusing on special cases. In the last video, we found a no solution through substitution, and today we're going to continue looking at the other special cases using substitution and how they are going to show up algebraically. I'll also show you the graph as well, so you'll have that. Now here you're going to notice this one is not easily set up for substitution. So we do have to strategize. Normally for substitution, I say pick the term. All right, so we've got 4 different terms here. Pick the term that's got no coefficient if it's possible. Well, unfortunately, we have coefficients in all of these. So then, that's not, we don't really have a path of least resistance here. We end up, or excuse me, that's not our path of least resistance here. So we want to strategize and maybe avoid fractions. You'll notice if we solve for the 8y and we end up dividing by that 8, we will be getting fractions. If we solve for the y on with the negative 20 and we divide off the negative 20, we will be getting fractions as well. That means the strategy says the 2x here, because 2 evenly divides into 8 and 6, is a good option. And negative 5x here is also a good option because negative 5 evenly divides into negative 20 and negative 15. Because I like smaller numbers, I'm going to go ahead and take that first equation and bring it on down. All right, so we are going to solve for x there, and I put a little note just to remind you of what I am doing. With that being said, it is important to note that when we are doing substitution, we have to take the goal is to get one of the equations isolated for one of the variables so we can so we can substitute it into the other equation. If we're solving for x here, we want to go basically from the outside in. I use opposite PEMDAS to guide me because we're doing the opposite of the operation as it appears, how it's attached to the variable. So we have a 2 attached to the x by multiplication. We also have a 8y attached by addition. In PEMDAS, multiplication and division do come before addition and subtraction, but we're doing opposite operation here. So we do undo the addition and subtraction first. In this case, because that 8y is being added, we are going to subtract it from each side. This is your literal equations knowledge. All right, notice we are working with variables here. We move them around just like numbers. They just don't simplify down the same way. Whenever we move that over, we do end up getting a negative 8 here, plus 6. Then I look, oh, that 2 is attached to that x by multiplication. I want it to divide off, because the opposite of multiplication is division. Now we can show it like this. It's important to know that everything is divided by 2. Some people will take this and put it over 2 like this. To form a distribution, you'd be distributing 1/2. However, I prefer to go ahead and show that distribution by every single thing being divided by that 2. We do this because the identity property, 2 divided by 2 is 1. 1 times x is x. And there we go. X is equal to negative 4y plus 3. That was a lot of work to isolate a single variable, but we have no fractions because we strategized. Now, all of this x will get substituted into the x in the equation we did not use. That is important. We do have to go back to the equation we did not use. Notice that would be the second equation. I'm going to take that second equation. I'm going to go ahead and bring it on down to the side so you can kind of see what we're doing here a little more clearly. All right, and just a note here. So notice I did put that x in parentheses. That x is going to go right here. Just to save us some time, I'm going to go ahead and write the skeleton out. All right, you'll notice that I wrote everything from that second equation and left x open. And I'm going to take all of what x is and substitute it in here. So that's all this x in here, and that is that negative 4y. I want to scrunch it in because I did not do good with managing my space. This is one of my major disorganization issues as a teacher, even on a whiteboard. All right. So there we go. We get a negative 5 times negative 4 at y plus 3 in parentheses minus 20y equals negative 15. If you do not put that x in parentheses, whenever you substitute, you will get this wrong. I just bluntly put it that way. you do have to distribute that -5 into both parts. And without the parentheses, you are not, that does not trigger you to do that. If we go ahead and watch that, we end up getting 20y, because negative times not, excuse me, because a negative times a negative is a positive. Almost said that wrong. Negative times a negative is a positive, and a negative times a positive is a negative. And then we have the rest of this here. That's that negative 20y equals negative 15. Now we do have some simplification, some like terms on the same side of the parentheses we could combine here. That is that negative 20, or that 20 and that negative 20y. So that 20y and that negative 20y. Well, 20 minus 20, well, that's 0, and 0y times, or 0 times y is 0. I said that fast. So 0 times y is 0, and those cancel out. We are left with two numbers, two constants. Negative 15 equals negative 15. What does this mean? All right. This is what we call a true statement in mathematics. Negative 15 will always equal negative 15. If these numbers were different, like they were in the first video, so if you go ahead and look up here, the first video in the series, the numbers were different. Only by sign, they were different. If they're different, then they're not the same. That's a false statement, and that's no solution, and they are parallel. In this scenario, these are the same. It is a true statement. So these are the exact same line. And when we have the exact same line, it is infinite many solutions. So if you'll notice here on the graph, there is only one line. If I were to toggle that purple line on and off, the black line on and off, you would see that they are the exact same line on Desmos. So that is the graphing calculator I used for these. So that is the difference. Infinite many solutions means the exact same line. There's more than one way to recognize that, either graphically, using substitution, getting that true statement. And that is different than parallel lines, which have a different point they go through, but the same slope on a graph, meaning they are two different lines that never intersect. And because they never intersect, there are no solutions. Same line intersects forever for every point. That's why they're infinite many. All right, I am going to go ahead and be showing you some videos using the elimination method for our special cases. Your math knowledge has just been patched on infinite many solutions achieved via the substitution method. Thank you so much for your time.